This map operation is to determine the core and how neural networks work, and to see the negative gradient to change the cost function, decrease the cost. And to view the crazy gradient function that is seen throughout the gradient function values. And the magnitude of the weight and the body determine the components instead is the cost function. Cost functions determine the nudges of weights. The nudges will determine the differences of what activation layer should be, and seeing which sample will be hitting each sample, and seeing which we'll focus on, and to adjust what values should be nudges and nudges should be activated. Since we want to get close to activation, we don't want to increase it. So we look back towards all the activations and to narrow down to seek the averages of each function, so that we could access the second layer and determine that to see if if to minimize it to activate the one that we want to, and to focus on weights and shift changing pretty strong influence on the cost function, and averaging the nudges and weights is another cost function, and minimizing the compute the cost function so it's not the most effective efficient way to trace back through the network to see how we can effectively fire the neurons and the activation layer, where the activation layers determine what fire each neuron determine that. As seen in this photo, we want to determine the activation layer to be 1.0 when we're thinking about 2, and we want to increase that propagation to see that, and to wire the neurons to be 2, and to see if we could do that is by seeing all the neurons and not really throw them in the trash, but to help that to see if the neurons could be fired back towards 2, and to average it out.